OPENDRONE project. We are developing an autonomous drone. Here, perfect. Here you can see our project team. We have me, Rasmus Hermren, as the project manager, and Linus Harenius as chief engineer. And other people that is in the team is back there. We had one mission during this project. It was to develop an open source UAV, and that is a drone, as some people call it. And the purpose of it was that it was going to be easy developed, and it was going to be dependable. We are from the dependable system program here at MDH. And our mission concept is that we have one drone that is taking data from a sensor, and you can see the sensor down in the corner. We are using Bluetooth on our drone, so we take data from the Bosch sensor and store that in the drone. And when the mission is done, we are running the drone autonomously back to the laptop, and our laptop is our main station. So later on, when the drone is back after the mission, we can take data from the drone, and we can use that to do different measurements. In this project, we have one company that is called AFA Cloud, and that company is using this in agriculture use. So they are taking sensor data from the sensor, humidity and temperature, to do different measurement of the fields on farms. We're using an open source flight control computer that is called PixOC4. We're using an autopilot called a PX4, and we also have a redundant system, so we can actually lose one gyro and one accelerometer, because we are using these different measurement tools to make the drone easier to fly and make it more dependable. And when the drone is flying, we can actually use different sensors to make it more dependable, and it will not crash because we have so much redundant in the drone.
So for the hardware structure, we have drawn everything in CAD, and then we have 3D printed it out, and you can see it at our monitor. For the software, we are using Q Ground Control, which is a graphical user interface where we can set all the parameters for the PixOC. We can also upload missions, as you can see on the picture, where we have all the information that we need when we are flying autonomously. For our first drone that we did, we call it Alpha 1, which was a small concept one where we got to know the PixOC and how to develop a drone, where we used the RC controller to fly it manually, but we also did some very simple missions using Q Ground Control. Our second drone that we were going to develop was Alpha 2, which was going to be bigger, but we had one simple problem, that it was not big enough, so we had to scrap this one. Okay, one slide is missing somehow. For our last version, we call it Beta, which was just to evaluate the materials. And here you can see that we were gonna use 3 versions. One was with molded carbon fiber frame with some fiberglass arms, which you can see on the picture. The second one was completely molded carbon fiber, and the third one was 3D printed carbon fiber. We did not have time to complete this though, because we lacked the time to just be able to evaluate this option. So for the final product, we are able to fly autonomously in quotation marks. That is because we don't have obstacle detection yet on this one. We will not be able to avoid collisions at all. The thing is that we have to plan all the missions also, so if we are flying in the path of a building, we will crash into it. So the operator has to make sure that the mission will be able to complete on its own. For the safety features, we also have fail-safe modes. For example, if the battery is running under a certain threshold, we will return to the position where we took off. We also have a fail-safe mode. If the battery is on an emergency level, we will land at its current position. So, summarized, the final product fulfills all the requirements and the objectives of the project. We are able to fly autonomously to a certain degree. We are able to take control manually whenever we want, as long as we have connection to the drone. We can collect data from a place sensor, and we can also demonstrate a certain degree of reliability and dependability. And now we have a video of one flight that we did that we will show. Yes.
And during this video, you can ask us questions. And we also want to inform you that after the launch, we're going to have a bigger presentation at MDH, Gamma, 13:15 till 15 o'clock. And during that presentation, we will also have a demo where we are actually flying the drone over MDH. And during this presentation, we will also show you more about the project, how we use our requirements to fulfill the task, and how we're using test cases and validation verification to solve the different problems that we occur during the project. So if you have any questions about the project, you can ask us now during this video. We are filming our drone with another Mavic Mini drone. So you can see the drone up. Now we lost it. Here you can see the drone, and we are flying above MDH, and we are collecting data from our sensor, as you can see here soon.
It's on the ground there.
Yeah. Here you can see a very, very small white spot, and that is our sensor. So the drone is flying over the sensor and taking data through Bluetooth, and then the drone is flying back to the starting point. So if you have any question, you can ask us now, or if you are wondering anything. And
I have a question.
yeah.
In this mission, did the drone know the position of the Bosch sensor?
Yes, we have to put it out, the GPS coordinates.
What is the resolution? I mean, plus minus what? Just from the location, I guess.
Yes.
It manages to go there anyway. I mean, like, not miss that much.
No, we try different, when we were doing different test cases, we put the Bosch sensor in different position, and then we flew into it and see if the GPS was going to be like misleading and so on. And the distance between the Bluetooth between the drone and the Bosch sensor is so big, so if the drone is like having a bit of lack of position, it will not be any problem, because the distance between the Bluetooth is so big, so it will still work.
Okay.
Jag tror att du kan byta till nästa.
And
And here you can see our out landing, and we are using a LiDAR on the drone, so we can land it perfectly. And we, of course, hope that you want to come to our presentation after the launch. And after that presentation, you can also see the drone fly in real time. Otherwise, thank for us, and thank you for listening.